Hi everyone, my name is Alex Lee, matrix number 145950 from Group Titanic.
Hi everyone, I am Yu Qi Jian, matrix number 146101. I come from Group Titanic. I hope you can enjoy our video project about logic combination circuit. For our case study, we will share with you on how combinational logic circuit apply to design an aircraft engine starting system. This system will consist of two switches considering as the input and three different colors LED indicators operate as the output. Before takeoff, the pilot and co-pilot of an aircraft have to carry out pre-flight safety check. When all checks have been completed, they each move a switch from the up to the down position. In this case, we assume that the switch provides logic level 0 in the out position and logic level 1 in the down position. When both switches are out, a red indicator on the instrument panel is on. This changes to yellow when at least one of them operates their switch. When both has operated their switches, a yellow and green indicator come on. The engines can only be started when the yellow and green indicator are on.
So, this is the logic circuit for the truth table shown before, and we will use it as our prototype. Next, the list of components we use in this project are 9-volt battery, breadboard, switch, connecting wires, 3 color LED, resistor, and 3 different logic gates. From the picture of our circuit, the logic gates are arranged in the order of AND gate, NOR gate, and NOT gate, from left to right.
Now, let me prove that our group logic combination circuit is functioning well according to the truth table. So, from this truth table, where input A and input B are both 0, only red LED will show logic level 1. So, when input A is grounded to 0 and input B grounded to 0, we see from here, the red LED will light up. So, when input A is 0 and input B is 1, yellow LED will light up. So, input A is 0 and input B is 1. We see from here, yellow LED light up. So, when input A and input B are both 1, the yellow and green LED will light up. So, input B is 1 and input A will change from 0 to 1. We see from here, the yellow and green LED light up. So, when input A is 1 and input B is 0, only yellow LED will light up. So, input A is 1 and input B will change from 1 to 0. So, only yellow LED will light up. So, this proves that our group logic combination circuit is functioning well according to this truth table. So, what happens if any of the input is left unconnected? What happens to the output? So, let's say we unconnect the input A. So, if you unconnect input A, for the output, the yellow LED will light up. So, if we unconnect both input A and input B, we see that the yellow and green LED will light up. So, during the floating process, the truth table is not followed, as we can see from this truth table. The yellow and green LED will only light up when input A and input B are both 1.
The first problem we face is no LED lights out after completing the connections. So, to solve this problem, we recheck the connections to make sure all connections are valid and all components are functioning. The second problem is that one of the logic gate is not functioning. What we do is we use the other pin number of the same integrated circuit as the inputs and output.